for the theory part, let's start and understand what is Java. Java is a programming language developed by the Sun Microsystems in 1995, which is now currently owned by Oracle. So it was a revolutionary language that was developed at first by the Sun Microsystem. Now next is, what are the different features of Java? These are actually important for theory point of view. So firstly, it is object oriented, that is in Java everything is an object. So what are the features of Java? These are important for the theory point of view. Firstly, it is object oriented, that is everything is an object. Java can be easily extended since it is based on the object model. Now what is an object model? So everything in Java is an object, that is object can be treated as a real world entity. That is, let us take an example of a bulb. A bulb is having its state like its color, its shape, etc. So we'll learn about object in further part. Next is, it is platform independent. That is, you can run your Java compiled code in any operating system regardless of any restrictions. And next is, it is very simple. Java is designed to be easy to learn. So we learn the basic concept of OOP, that is object oriented programming, and it is very easy to master. With Java secure feature, it enables to develop virus free. That is, whatever code you write in Java will be secure from any virus attacks, right? Architecture neutral, that means that any compiled Java code can be run on any kind of architecture. We have many kinds of architecture. Some examples are 32-bit and 64-bit architecture. So it is architecturally neutral. So what do you mean by robust? Robust means that Java programming language never fails automatically. Why? Because we have exception handling and garbage collection, automatic garbage collection rather. Exception handling means that any exception that is raised by our logic, it is automatically handled by the JVM. And next is automatic garbage collection, that is memory that is allocated during runtime and is no longer in use, it automatically deletes that. Next is portable, easy to carry and install. That is, once you compile your Java code, you can take that compiled file anywhere and install it in any operating system. Now next is applications of Java. That is how we apply the concepts of Java. First is multi-threaded. Java performs multiple tasks simultaneously. For example, take an example of WhatsApp. At the same time, we are also receiving the messages as well as sending the messages. So that is multi-threaded. We are performing two tasks simultaneously. Next is interpreted. That is, Java byte code is translated on the fly to native machine instructions and it is not stored anywhere. Now that means that each and every line of Java code is interpreted and it is not stored in the machine. That is, you are not supposed to store the whole code in a machine. That is, it interprets one line and executes it. High performance, that is, with the use of just-in-time compilers, you may have come across the terms JIT compilers. The full form is just-in-time compilers, which enables high performance. Java is designed for distributed environment of the internet. That means that Java can be run on any platform or any environment of the internet. Okay, be it a web browser, for example, the applets. Now next is memory is reserved at runtime. I told you earlier also that the JVM automatically does the work of garbage collection. So any memory that is used by your object is automatically cleared if it is out of the scope. So now let's understand how Java compiles the code. Firstly, you take the source code, that is a .java file. When we'll go into the coding, I'll show you the .java file, and then when you run it, or I'll say when you compile it, Java compiler, the JIT compiler does the work of compiling it, right? Now that .java file is converted into a bytecode, that is a .last file. Why is it called bytecode? Because each character in bytecode takes 1 byte to be stored in the hard disk. That's why it was given the name the bytecode. Next, the bytecode generated is run by the JVM. Now note, JVM is very much OS specific. That is, JVM will be different for Mac and different for Windows as well as different for Linux. Dot class file is independent of OS, but JVM is OS specific, right? Now the OS specific JVM takes the bytecode generated and interpreted it line by line. Now the machine code that is generated is also OS specific, right? So now after that it executes the program and you get the output. Now when we consider a Java program, it can be defined as a collection of objects that communicate via invoking each other's method. A class can be defined as a template simple blueprint. For example, let's take off our human body. Our human body can be referred to a class. We have our state, we have our different behaviors, okay, like we have 2 eyes, 1 nose and 1 lips, but we all are a type of human beings but are different in each of our respective nature, color, etc., right? Now next is methods. A method is basically a behavior. Like in a class, for example, let's take a human class only. In a human class, I'll declare a method eat. So every human will have the property of eating. So what is a method? It is basically where we will write the logics. So it is written that in eat method we will eat the food through our mouth, right? So that's where the logics are written, data is manipulated and all our actions are executed. Like sleeping, eating, walking, it is associated with object, not class. So methods are object specific, that is my eating will be different from your eating, okay? Next are instance variables. Now what are variables? Firstly, variables are a quantity, a data set that is used to store and manipulate the data. We'll see when we code what are variables and different types of variables. So each object has its unique set of instance variables. By instance, you can refer that it is very much object specific, that is every object. For example, I'm having a purse. Now my wallet balance will be different from your wallet balance. Why? Because my variable of storing the data or storing the amount is different and yours is different, right? So an object state is created by the values assigned to these instance variable. Okay, so what determines the state? It is the instance variables. What determines the behavior? It is the methods. So whenever any interviewer or any question is asked that what determines the state of an object or class, it is the instance variables. And what determines the behavior of an object or class, these are the methods, right? So this was important to understand, and let's now start writing a code. Remember, Java is object oriented. Everything will be written in a class, okay? Everything will be written in a class and Java is object oriented. That's it. Now let's start and begin writing our first Java code. So I have opened Eclipse. You can download and install any IDE of your choice. And now let's click on File and make a new project. And click on Java project and click next. Now here I'll give it Java learning. So click on next and click on finish. So as you can see that a new project is created inside source. There is no file. So firstly I'll create a new class. Now what are class? I'll tell you while we code. So let me just name it a tester class and click on finish. You can see automatically a package is created with the name Java learning. So this is our public class tester. Now what is public, what is class, and what is tester? Now this tester is the name of the class, as you would be knowing, and this class is a keyword. That is, it determines and tells that this is of a type class, right? And what does this public means? It is an access specifier. That means if we declare any class public, any file or any package can get access to that class, right? If we declare it protected, then any file but inside a same package can access the class. That means, see, we have a package known as Java Learning here. If I just make a new package and create it protected, right? If I just give it a access specifier protected, then the other file or other package will not be able to access it. Okay, so now let's start writing our first program. As you see that we have a public class tester, and I already told you why public and what is class. So next is, let's declare our main method. What is a main method? Main is a very special method that is known to JVM, and it needs to be public as well as static. First I'll write the method declaration and then I'll explain it. So I'll write public static void main, and inside this it will take a parameter of string name your wish, and then that's it. Now for declaring methods, it starts with curly brace and it ends with curly brace. That is, anything that I'll write inside these curly braces will be executed if the main method is called. Now why public? Because see, Java or JVM needs an entry point to start the execution of our program. So main is a keyword that is reserved by Java, and it determines that this method will be called the first time, or initially this method will be called by the JVM. It needs to be public because JVM is external and it will be externally calling this function. Why static? Static is not associated with any objects. We'll learn about static, don't worry. So static because it needs to be executed only once, and as soon as the class is created and this method is called, right? So next is void. Void means empty, that is, it is not returning anything. We'll see what our function returns and how we can return a value. So anything that I'll write inside this main function will be executed first. So this so in other words, this void main function will represent the flow of our program. So let's start printing something on our console. To print anything to the console, we have to write system. Now see, S is capital here, so that means that system is a class. So there comes the name conventions. While defining any class, then first alphabet should be capital and rest will be smaller. In case of tester also, you can see that T is capital. This is also known as camel case. Now dot write out. See, out is a instance variable of print stream from the system class, right? Put a dot and then write print ln. Ln means that each output will be in a new line. So put a semicolon, and inside this println write whatever you want to print. So I'll write hello world, right? So let's save it and click on this play button. Now you can see hello world is printed on the console. So any class name starts with a capital letter, it follows a camel casing, and the method start with a small alphabet, right? See, main is not with capital MAIN. It is not defined in JVM. It should be MAIN with M small, right? So JVM automatically identifies this method and calls it as soon as you execute the program. So we wrote our first program. Now let's understand different data types. So in Java, data types can be broadly classified into two, that is primitive and non-primitive. Now you can see primitive are inbuilt ready mode data types and non-primitive are user defined. Now what do you mean by inbuilt ready mode? That is, you can use them as it is and they have very much fixed size. So in inbuilt data types we have two, Boolean and numeric. Boolean can take two values, that is true and false, and in numeric we have integral and float. Now inside float we have all the decimal numbers, and in integral we have all the integer numbers, right? So in integral we have two classes, that is integer and character, character is of 2 bytes, and integer can be further classified into byte, short, int and long, where we'll be using int and long most of the times. So byte is with 1 byte of space, short takes 2 bytes of space, int 4 bytes, and similarly long 8 bytes. So you can take a screenshot of this chart and take it for your reference. And in user defined data types, we have class, interface, array and enum. In non-primitive data types, size is not fixed. That is, we can declare n number of variables inside class and it will take the size according to the variables that are used. So variables that we'll be using will be of the type of primitive data type. All the variables that are using primitive data type will be accumulated or combined to form a non-primitive data types. Non-primitive data types is basically a collection having, or rather I can say that a collection of different data types. For example, in a class we can declare different data types. Now let's see how we can declare the primitive data types, and then we'll move on to the non-primitive ones, right? So let's begin declaring our variables. Now let's start declaring our variable. Now you might ask, what are variables? They are just a name or label given to a memory location, and that memory location used to hold the data. So for that, let's write int a. I'm not giving it any value. Now see, this int without given any access specifier takes a default access specifier, right? We'll discuss about default, don't worry. Let me just give it a public specifier. That means that this variable, this a variable, will be accessible outside this class also through objects, right? So next let's declare a float variable, float b. Let's declare a character, maybe c, right? Let's declare a long variable. Let's declare a double variable. And declare a boolean variable. Now as you can see, I have declared all the variables. So what is the manner in which you have to declare a variable? Firstly, the access specifier. Now these access specifiers becomes important if you declare them inside a class, that is if they are object related. If you declare all these variables inside this main method, then you need not to give the access specifier because the variables are local to the variables. For example, if I write int d here equals to 0. Now see, this d will be available only inside this main method and not accessible elsewhere. I need to initialize these variables here because local variables needs to be initialized. If I don't give anything here, right, I just give int d, and if I try printing d here, let me save it, and you can see an error. That is, the local variable d may not have been initialized. That means you have not given any initial value to it. So that's why I don't equals to 0. Initially d is holding value 0, and then it can be further updated based on our needs and requirements. But see, in case of these variables, these are all object level variables. These need not to be initialized because JVM automatically gives a default value to these variables. Now let's understand what are the default values that is given by JVM automatically to the instance variables, that is all the variables that are declared inside class. For variables that are declared inside a method, I'm repeating again, for the variables that are declared inside methods need to be initialized, given an initial value. Whereas for the variables that are declared inside a class and outside any method need not to be initialized, as the JVM automatically gives a default value to the variables. Now let's see what are the default values. I'll also verify it by running it. First let me tell you what are the default values. For integer, the default value is 0. That is, a will be given 0 value automatically. For float, it is 0.0 f. Now f is a keyword or a literal for representing float variable. For character, it is /u, 000 and one more 0, 4 zeros. Now this represents a null value in Unicode system. That is, in Unicode system, u 4 times 0 is for null. For long, it is 0 L, though it will be capital L. For double, it is 0.0 D. Now this D is optional. You can write D or not write D here. D is once again similar to long and float, a representation for the variables that it is type of double, float or long. For Boolean, the default value is false. False with small f, right? So these are the default values that are given by the JVM. So for printing the values of these, so now let's see how to create an object. Firstly, you write the class name tester. Now the object name. What is an object? Object is a reference variable for a class. Yes, it is given some memory and reference ID. I'll write tester1. Now one more thing, all of the variable names need to start from the small alphabets and should not start with any numbers, or any special characters are not to be used. No spaces. However, underscore is permitted. That is, you can write tester1 but not tester space 1, and you cannot name the variables as one tester. It should start with an alphabet, and name them, it follows a camel casing approach. That is, first letter should be small in this case. So next, put a equal to sign and write new. Now what is the function of new? We'll discuss it, don't worry. And write the class name and with brackets. Now this here denotes the constructor. We'll see what are constructors. This is a reference variable that is given some memory and some reference ID, and this is the type of that reference variable. That this reference variable is of the type tester. See, we discussed that we have integer types, we have float types. Similarly, we have a tester type now. That is, this tester type is defined by us, the user. Now let's understand what is the function of new. New is a keyword reserved by JVM. Whenever this line will be executed, this new keyword, using this new keyword, a new memory location will be given to this tester variable. As soon as this constructor is called, that is, this line, this portion is called or executed, default values will be automatically given to these variables, right? So let's try printing them. So inside this, how to access the instance variables from an instance? Just write the instance name, object name, put a dot, and you can see all the variables that are accessible. Now one more thing, let me just explain it to you. If I remove this public from here and write private. Now private are those variables that will not be accessible anywhere outside a class or anywhere through an object. So just see, if I put a dot here, you can see all the variables, but the A is in red, that is, it is not accessible using the object. So if you want to save some variables that should not be accessible outside the class, you declare it public, you declare it private. So by default, it is a good convention and practice to declare all the variables private. हो गया?
आउटसाइड द क्लास ना, पब्लिक तो सेम क्लास में है.
अच्छा भैंस की, हाँ.
पब्लिक इज अ मेथड ना, ये नॉर्मल मेथड है कि बस जेवीएम को नेम मेन पता है.
अच्छा,
जस्ट लाइक अ मेथड ऑफ अ क्लास.
हाँ हाँ, ठीक है, ओके, चलो. So to print the values of these, let's see how we can access the variables. We write the object name, dot a. Let's try printing it. Save it and we'll run it and see. So you can see that a 0 is printed here. So the default value, see, we didn't give any value to a, but as soon as this constructor is called, a is given a default value of 0. Now let's try with b. Save it and run it, and you can see 0.0 is printed. Now this f here is for denoting it is a float value, right? So next is c. Let's give it c. Save it and run it, and you can see nothing is printed because this is denoting a null value. So null is not printed, right? So it is a null value, nothing, right? So let's give it d maybe. So by d, run it, and you can see a 0 is given. So 0l. L denotes a long variable. We have to write these when we are declaring the variables as to specify the data type. For e, let's try running it, and you can see 0.0 is printed. Now see, for double also it is 0.0, and for float also it is 0.0. This letter here determines the data type that is to be used, right? For boolean, let's print f here and give it a run, and you can see false is printed. So these are the default variables that is given by the constructor there. If I just remove this and try printing only d, see, d need not to be accessed through the object. This is a local variable that is accessible only inside this method. Now it is giving me an error that this needs to be initialized. This is how we declare any object. Let's just try and print the object itself. So if I run it, okay, so if we print this object, we can see that java-learning.tester, this is the package name and this is the class name, at that this is the reference ID for our object, right? Now let's try creating a new object, tester2 here, and so this is the way to create an object. And if I print tester2 here and run it, you can see both the objects are having different reference IDs these are stored in different locations, having their unique set of variables and methods, right? So let's try giving it, okay, let me write it here, tester.a equals to 10, right? I am giving a value to the tester.a method, that is this integer value. And if I write tester2.a equals to 20, what should be the value of a? Let's try printing it. Tester2.n, 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 and if we run it, you can see different values. So this object has its own set of values and this object has its own set of variables and values. So any changes that is done in this object is unique to this object only and will not be reflected to this tester object. Okay, so now let's create a simple method, right? So for that you have to give the access specifier. We'll write public, that is it should be accessible outside the class using the object. Every method by convention is declared public because see, these methods we need some or other method to interact with the variables inside the class. So the methods are used to interact with the variables that are inside the class. If we declare all the variables private, now these variables will not be accessible outside the class even using the objects, but using these methods we can access that. Now this ensures safety and security. So we'll write public void. Void means null or empty value, that is it will not return anything. We'll see what does return means, and I'll give the name of the method display. So this is how you declare a method, just same like this main. In main we had the static keyword that just tells that it is not associated with any object but with the class. Now inside this I'll put a sysO. Now see, this is a shortcut to write the system.out.println, right? SysO and press Ctrl and space. It will automatically complete. Now inside this, let me just write this is a display function. Now you can give any name to this function, and let's just print some values like this dot, okay, like a. Now see, I didn't mention anything here, any object here, because this method will be able to access these variables because it is local to the class here, right? So let's just call a method. How to call a method? You just write the method name with a curly braces and semicolon. It will automatically call this method. So now let's understand what are the return types and how to return some value from a function, right? From a method A. So we'll write public and we'll write a string maybe here, string, and we'll write return string here. I'm giving this function a name return string, and inside these curly braces I have to return a string. Now what is a string? Any line or any line containing all the characters. A collection of characters is known as string. So inside this string I can return like this is from return string method, right? So now what does this mean? That whenever I'll be calling this function return string, it will return this string from it. So think of a scenario where you tell someone to bring you a glass of water. The person will perform the task of bringing you the glass of water. He'll bring you the glass, but you have to hold the glass with your own hands, right? He'll give you the glass, but if you'll not lift your hands up or hold it with your hands, it will not be caught by you, and it's supposed that you'll be wasting that glass of water. So similarly, if we call this function return string, this will return a string, but we need to have a variable which will store or which will catch this string from this method, right? So let me just explain you. If we simply write return string here, again will not be able to call, so it's a object function, so we'll write tester.return string, right? So I'll just call it and run it. See, nothing happens. Why? We called the display function and it displayed, this is a display function, and printed the value 10. Then this SOPs printed the value 10 and 20, but this function did not return anything. Actually, it returned a string, but we were not able to catch it. So to catch it, rather I can write it in system.out.println, and I'll just copy it. Let me just copy it from here and put it inside this println function. Now see, whatever this function will be returning, this method will print it. So we have something to catch whatever this is returning. Now let's give it a run and see what happens. There you go. You can see that this is from return string method is printed because we were able to catch the string which it is returning. So similarly, we can return an integer value from it, but this return type is string here, so we have to convert it into int. So now let's save it and run it again, and we can see this 10 here is from this function, right? Let's just change it to what it was before. And now this is one thing. Next is we can also declare a variable, string some variable, maybe catcher, and this will hold whatever value will be returned from this function. So I can write tester dot return string. So whatever will be returned from this method will be caught by this catcher variable. Let me just remove this, comment this out, and now I'll print catcher here. So you can see that same, this is from return string method will be printed. We were able to catch whatever is returned by this method and we were able to print it. We can similarly catch an integer value also if it will be returning int here. So what do you understand from this? Return type of this method is integer, then the catching variable should also be the same data type, right? So this is how we can return a value from any functions. Now okay, so the next topic will be how to typecast variables. There are different types of typecasting, that is explicit typecasting and implicit typecasting. What is typecasting? Changing of variables, or we can say that changing of data types is known as typecasting. That type is changing. Now the typecasting, as I said earlier, is of two types: implicit typecasting and explicit typecasting. Implicit typecasting is also known as widening. That is when we convert small data type to large data type, and it is done automatically by the compiler. That is, it is done internally. Let us see an example of it. So let's just remove all this. Let me just comment it out so that we can focus only on typecasting by the time, right? So let's see. I'll declare a variable with byte, maybe byte b equals to 10. So what did I told you, that when we convert small data type to larger data type, byte is small. What is the larger data type? Integer value, right? So I'll write integer c equals to b. Now what does this line mean? That value of b is assigned to c. C byte is say b is of type byte and c is of type integer. Integer is bigger in terms of size, so integer can very easily store the value of byte. This is known as widening and also known as implicit typecasting. That is done by the compiler itself. We are not supposed to write anything, right? Let's just print it and see. So I'll write b, and then next line I'll write c. Now let's see what happens. We'll run it and save it and run it, and you can see 10 is printed both the time. That is, this c was able to convert this byte into integer. So that is known as implicit typecasting. Fine. Now let's understand what is explicit typecasting. Now this is explicit typecasting. Now it is when we convert large data type into smaller data types, and it is also called narrowing. That is, large data types are converted into smaller data type. That is, we are narrowing the space that it will be taking. It is done by the user itself. That is, we'll be doing it explicitly. Compiler will not compile it. Let's take an example and see. Int x equals to 10, and now let's see byte y equals to x. There you go, you can see a red line here. That means byte is unable to store x which is of larger precedence or larger space. That is, x takes up 4 bytes whereas byte can take only 1 byte. So how can it store 10 which is taking 4 bytes into a single byte? So for that we can write byte here. In brackets before the variable I'll write byte. That is, in byte y, copy the value of x, which is now stored inside a byte type, right? So this is known as explicit typecasting. That is, we are doing the typecasting. We are forcing the compiler to convert this variable, which is of type integer, into byte. Now this is not actually preferred because it may result in data loss, right? You think yourself that integer x is storing 4 bytes, so 10 is stored in 4 bytes and we are forcing to store it in a single byte. Okay, so now let's discuss a very unexpected behavior of Java that is still unanswered, and we don't know, and nobody knows the answer. So let me just tell you how unexpected. So unexpected behavior of Java. Let me just declare a variable byte d equals to 10 here, right? So now this d is holding a byte and value is 10. Let me declare another variable e with the value 20. Now this is very much clear that d and e are both byte types and are storing 10 and 20 values respectively. Now if I write byte x equals to d plus e, byte, okay, x is duplicate value, let me just give it f now. So if I write byte f equals to d plus e, it is giving me error that type mismatch, cannot convert from integer to byte. We have declared both this variable byte, that means now 10 plus 20, it is converting it into integer, that is 10 plus 20 is 30, which is a integer, which is an integer constant, and this integer constant cannot be converted into byte. So okay, now that is, we have to convert it into byte explicitly. How to convert it into byte explicitly? We write byte here and we'll put this in bracket also. Now the result of d plus e will be explicitly converted into byte, but why it wasn't able to store it in byte, it is still unexplainable and unanswered by Java. Now why is it unexpected? Let me see. Let me just tell you. Float a equals to 10f. See, this is how we declare a float variable. We have to write the f. Now f will not be included in 10, it is just for referring that it is a float value, right? So float b equals to, not b, I'll just give it, right, g equals to 20f. Now both these are float value, and if I write float j equals to a plus g, this will not give any error. If we add two float values, it is convertible into float. This variable is taking the result, but in case of byte it is not taking. That's why it is unexpected behavior and it's still unanswerable. So don't worry, we don't play with bytes very often, so we only have more we only use these float double data types. So but still, it's just a funny unexpected behavior that I wanted to share with you, just for knowledge. So that's how we typecast it, and we have one unexpected behavior, otherwise it will typecast it, right? Static block, static data types, and static members, static methods, right? So I'll just delete all these lines and then let's understand what is a static method, static block, and static variable. See, you can see we used a static keyword in main. So this method is automatically a static method. Any method that is declared using a static keyword is a static method. Now what do you mean by static? The portion of a class which is getting a memory at class loading time. that can get the memory only once in the life cycle of the class, this process is known as static memory allocation. That is, it will be executed only once during the compile time only. That is, when you are compiling, only then this method or variables will be declared or executed. Now next, contrary to that, we have dynamic memory allocation. That is the portion of class which is getting a memory at runtime, that can get memory again and again in the life cycle of the class, is known as dynamic memory allocation. Now let me just give you an example. This main method, as we declared it static, will be called only once during the whole life cycle, whereas all these variables can be called and created as long as we keep creating different objects of this class. So all these variables are dynamically allocated. And let me just create a static variable also. So I'll write public static int sv, right? Sv for static variable. Now whenever, so at first when this class will be called, this static variable will be initialized with the value, what is the default value? 0. Now if we call, or if we make another object of this class, suppose I have given this as 1 value. If I create 10 objects, suppose if I create 10 objects, now for that 10 objects the value will be 1, right? Suppose on creating each and every object I am incrementing this value. That is, whenever I create a new object, this value is incremented by 1. So at the end of creating 10th object, the value will be 10. Now if I access this value from the first object, the value will still be 10, not 1, because the static block or static variable is class level. So firstly, when to use static? Always keep those property of an object as a static data member of a class whose values are same for each object. So let me just give you a scenario to understand the static better. Suppose we are creating a software for a company named ABC. Now name for ABC, that is, we are the employees, or for any employee the employer name will be ABC. So we'll keep the name as static, that is, the name ABC will be common for all employees. Every employee will have the employer name as ABC. So whenever we'll change the company name, that is, whenever the company decides to change its name to ABCD, suppose, now that name will be reflected for all the objects, right? So next is that all the static data members are getting a memory at class loading time, that means before execution of the main function. So this integer value, even before executing this main, gets the value as whatever we are declaring, right? So there is a static block also. So how to declare a static block? Static, and inside this we can just give a sys statement, static block. So even before this main method here, static block gets executed. Just give a sys here and from main, right, from main. Now let's try and run it. There you go. Static block is printed first and then from main. Sorry for the spelling, it is from main. And see, static gets executed even before the main. Okay, so because it gets executed during the class loading time. So next is that all the static members are getting a memory only once in the life cycle of the class. Once a class is loaded, that's it. Now once a class is loaded, now suppose if I create a new object, this static block will not be called. This static gets executed only once in the life cycle of the program. So you understand? Right? So this was all about static block, static keyword, static variables and static method. Now let's understand this with an example. Suppose I give it a static name with public static string name, and I'll give it ABC. So we have declared a static variable ABC. Now let's create some objects for this. So how to create an object? We write the class name, then the name of the object. Let me just give it T1 here. We'll declare it with new tester, right? So a new object is created. So we have created a new object. Now let me create another object and see two objects. We have two objects. Now if I just print tester dot name, now see I accessed the static variable with a class name. That is, you need not to have any object to access the static variable. You can access static variable using object, but you should never access the static variable using objects, as whenever you create an object, a different separate memory is allocated to the variable and the memory will be wasted. You can see that ABC is printed despite creating two objects. The value will be same for all the objects. That is, it will be common for all these two objects. Now let's try it. I write t1.name equals to xyz, right? So what am I doing here? I am changing the name variable to xyz using an object. That's it. That is, we change the company name for one object. Clear? Here I'll print t2.name. Now see, for a simple variable that is not static, value for t1.name will be different and value for t2.name will be different, as all different objects have different variables and different values. But as the name is static here, see, this string is static. That means that this variable will be common to all objects. So any change that is done from one object also is reflected to all the objects. Let's give it a run and see. Let's save it and give it a run. And you can see, even if we have changed the value from T1, the change is reflected in T2 also. That is, static is common to all. So let's start with OOPS. OOPS stands for Object Oriented Programming System. See, in the starting only I told you that Java follows a OOPS approach. That is, Java is an object oriented programming. So for any language to be called object oriented, it must follow three principles. You can remember those three principles and concepts by this word pi. So for pi, P stands for polymorphism, inheritance and encapsulation. Right? P stands for polymorphism, I stands for inheritance, and E stands for encapsulation. Don't worry, we'll study each concept one by one. So let's start with polymorphism and see what you mean by polymorphism, right? So let's start with polymorphism. But to start with polymorphism, let me just remove this object. This is not it. We'll see it by one object only. So what do you understand by polymorphism? Polymorphism, right? Polymorphism was made from two words. First is poly, that means many, and second was morph, that means forms. So that means Java, if we say that Java is object-oriented programming language, that means it must support polymorphism. So whenever an object gives a different behavior in different circumstances, this behavior of an object is known as polymorphism. That is, let me just show you with an example here. I'll declare another function. Let me just write void here, and instead of return, I'll write a print statement, return new parameters here. So if I say that Java supports many forms, that is same name but different behaviors, so by this definition I can say that it must allow to declare different functions with same name. But you can see errors being shown there. Why are these errors? Because by this time, if we declare two functions, our compiler is confused which function to call. Now see, if I call a function t1.display, now there is ambiguity, there is confusion which function to call. It doesn't know what function to call here, right? So how to remove this ambiguity? There are some parameters based on which our compiler decides which function to call. Those are the number of arguments, type of arguments, and order of arguments. Now what are arguments? Now let's understand what are arguments first. So arguments are the variables that are passed in the parameters of a function. That means in the parentheses, if I write string s, right? So that means that I can pass a variable value of type string inside this function, and I can use that. Understood? Now see, the error is gone. Why? Because this function is not having any parameters, and this function is having some single parameter. That means instead of no parameter, let me just print s here, and I'll comment this function out. Understand how to pass value to this. Now see, formal entry. Now see, this function call is giving us an error. The method display string in the type tester is not applicable for the arguments 0. That is, you can't pass 0 arguments here. You have to pass 1 argument because we have declared 1 argument. Now this argument is known as formal argument, and this argument is known as actual argument. And let's understand this. Whatever I'll pass in this call function, in the calling of the function, are known as actual argument. That is, I'll have to pass a string here, so I'll write welcome. Let me just write welcome in. Give it a run and see what happens. So you can say welcome is printed. Now this welcome that I passed in place of the actual argument was copied in this string s, in this variable. Now this variable is responsible for the data flow. Now this got inside this variable, and I am printing s, not welcome here. So whatever I'll be passing from this function will be printed inside this function. Now these are the arguments. I can also pass an integer along with this string. So now see, you can see an error here because it is respecting 2 arguments. So make sure you are passing the valid number of arguments, as well as the order is also maintained. Here we have string first and then an integer. So I have to write integer after the string, then only it will be valid. If I write 10 before welcome, it will give an error saying that type is mismatch, right? So don't do this. Also always maintain the order in which the formal and actual arguments are presented. So This was all about passing arguments, and next is polymorphism. So next is polymorphism, that is many forms. So let me just declare rather uncomment this function. Now you can see there is no error. We have two functions with same name. So what are the deciding factors, or rather I can say what are the differentiating factors between these two? It is the number of arguments. This function is not having any of the arguments. This function is having two arguments, right? I'll just write no arguments. So tell me one thing, if I write this line, which function will be executed? This line. Along with display function, I'm also giving two arguments, that is one string and one integer value. So it will decide based on the number of arguments here, and it will automatically call this function. Now let me just remove this. Now which function will be executed? This function will be executed because it will differentiate based on the arguments. It is not having any arguments. Let me just run it and show you. No arguments, that means this function was called. And if I write here some string, maybe let me just write s and 10. Now which function will be called? The upper one, which is having, you can see s is good. Now one more thing, suppose I have two arguments in another function. I'll create another function, public void display, right? And I'll give two arguments here, but instead of giving string and then integer, I'll give first integer and then string, right? So okay, I messed up with the brackets here. So there you go. Still you can see there are no red lines, no errors. Why? Because now compiler can differentiate based on the order of the arguments. So what are the three factors? First was the number of arguments, second is the order of arguments. Now if I pass, let me just write changed order right here. So if I run it, you can see s is printed here because this function was called, because inside this function we had first string and then integer. Now what if I pass first an integer and then a string? Now which function will be called? Yes, you guessed it right. This function was called because order of arguments matched here, right? Now we have discussed two types, that is number of arguments, and second was the order of arguments. Third is based on the type of arguments. How do we do this? Let me just change all the types. I'll just give it a byte A, and here I'll give it a long A, and here I'll give it short A, right? I'll print it. Now let me write long here, and I'll write byte here, and I'll write short here. After this, let me just make another function with the same name, but this time the parameters is of type int, right? So I'll public void and write integer, right? So in the calling, I'll write display 10. Tell me which function will be executed, because I'm passing 10 and integer can also take up the value of 10. Short will also take up the value of 10. Even byte can store 10, and as well as long can also store 10. So it will match the type. 10 is an integer constant, so it will look for the function which is having integer as a parameter. So this function will be called. Let me run and show you. There you go, integer is called. So it is differentiating based on type. Now let's see one more Fun fact. Now let's see one more fun fact. I'll just comment it out. And now tell me which function will be called. See, 10 is an integer constant and it will look for an integer in the parameters, but none of them are integer. So for this it will look for a variable or data type which is higher in precedence with the integer. That is, see, short is having less number of bytes than integer. Even byte is having 1 byte, short is having 2 bytes, but long is having 8 bytes. So which function will be called? Yes, this function will be called, because it will look for the data type which is higher in precedence. This is also known as data type promotion in Java, right? So let's just verify it and run it, and there you go, long is printed. That means this function got called. And let's understand this further. I'll comment this long out. See, I have commented this out. Okay, now you can see in red line why it is showing some error, because 10 is an integer constant and it cannot fit up in byte or short. Why? Because integer takes up 4 bytes, whereas byte and short takes 1 and 2 bytes respectively. So we have to convert it explicitly. I can write byte here. There you go. If I write byte here, now it knows that it will be calling this function. Let me just run it and see. And you can see byte is executed. So this is how our JVM decides which function to call. And this is also known as polymorphism. See, polymorphism is a concept. The process which it is following is known as the function overloading. Right? Same name and different behaviors, different functionality. This is known as function overloading as well as polymorphism. Now let's understand what is inheritance. Before that, we have to discuss a concept known as constructors. We'll see what are constructors and how are they used. So let's see. Constructors, let us make a new class. I'll empty this tester class because we'll be using it to test our code or test the functioning. So let me just empty this out, and you can see that our tester class is now empty without any code. See, one more concept, that at least one class should have your main method, because this will be the entry point for our Java program. So we need to have one class which is having main function. Otherwise all the other classes are supposed to have only the behavior and states. Make sure that the class which is having the main method is public. Take a note of that. So now let's, inside our package, let's create a new class and I'll name it employee. So we have another class employee. I'll declare some variables here, private and salary. That's it. That's enough. So this employee is having some salary, and let me just create another variable EID also, right? And a name, private string. Name is of type string. I guess you are now comfortable with the data types by the time. Now, why are these variables private? Why have I taken these value private? Because I don't want any other person to change the salary, EID or name of the employee. So if I declare any data type, if I declare any variable private, it will not be accessed outside the class, right? So okay. So next is, how do we access these variables? We have getters and setters for that. What are getters and setters? As the name suggests, the get method will be used to get the value of the data type, to get the value of the variables, and the set methods will be used to set the value of the variables from outside the class. See, inside the class I can easily write salary equals to 200, but normally we don't write any code inside the class like these, right? We don't set any values inside the class. So we need some methods that can interact with the variables from outside the class, because we will be dealing with the objects and not classes. So how to get them? Firstly, very simple method is go to your source and click on generate getters and setters. Select all the variables that you have created and click on get it. You can see that these getters and setters are automatically generated. Now let's see what are the functions of this. Now see, public int get salary, that means this is a public function. See, our data variable data members should be private, but each and every method must be public, because if they are not public, how will we be able to access them outside the class, right? So public int get salary, that means it is returning an integer value. And what is the integer value here? Salary. Always take care of the names that you are giving. See, method name should start with a small alphabet and rest is the camel casing that will follow. Next is public void set salary. Now when we are setting some value, we need not to return anything from it. That's why it is of type void. Set salary, if we want to set any salary, if we want to set salary for an employee, we need to pass some parameters here also. That's why we have declared an integer salary parameter. Now when we'll be calling this function, whatever will be passing inside the parameters of this calling function, it will be transferred to the salary of this. It will be transferred to the salary of this class. Now you can see this dot everywhere inside the set method. Now let's understand what is this. This is acting as a pointer which is pointing to the current object reference. That is, suppose we created 2 or 3 objects for this class. Now this will make sure that for the particular object from which you are calling this function, for the same object only the value is passed. So when this code is compiled, the compiler automatically converts this into the reference of the object from which the function is being called. So let's understand this. We'll go to the tester class and we'll create an object of an employee. So how to create an object? We'll write the class name employee1 equals to new employee, right? Sorry. Right. There you go. Now let me just create another object e2. Right. So if I write e1 dot set name, it is expecting a string. So I'll just write here row1. Double here. Whenever I'll be calling this set name, you can see this set name, set ename there. Now this will be pointing to the E1 object here. So inside this, what will be stored? The reference of this E1. So whatever you will be passing inside this function, it will be particular for this object only. That is, only E1 will be having the name value as row1, and E1 will have a null value. Right? We discussed that whenever we create an object, it gives the default values to these data types or data values, right? So I hope you are okay. So this was the functioning of this pointer. Now next is the constructor. Okay, so one more thing. Suppose I want to initialize some value to salary, EID and ENAME. Now, okay, the JVM will do the work of giving some default values. For salary it will be 0, EID it will be 0 and ENAME will be none. But what if I want some default values that must be given by me or by the company and not some null or zero values? So we can do that by using constructor. So whatever we have learned so far, using those concepts only, how are we supposed to give some default values to the objects? We have to call set methods on each and every object. Like I'll be like ename here, and I have to write even dot set eid to maybe 10, and then e1 dot set salary to be 10,000. So there you go. For each and every object, we have to call the set methods. Now this becomes very hectic, and to counter that, we have the concepts of constructor. Now what are constructors? Let's understand. Constructors are the special member functions of a class which are used to initialize an object. Now see, we have written employee e1 equals to new employee, putting the values of an object while creating it. This process is known as object initialization. So let's understand. See, when we created this e1 object, employee e1, this is the type of the e1, and we wrote new employee and with the okay. So now see, we have to as I told you that we had to write all the set statements here. Suppose we want that as soon as the object is created, these default values are given to the variables that we have inside the class. So for that, we have constructor C, employee e1 equals to new employee, and then we have parentheses. Wherever we use these opening and closing parentheses, it means that we are calling a method. We don't have any method here with the name employee. Okay, so constructors are special member functions of a class which are used to initialize an object. So this line is initializing, giving initial values to the class variables here, right? The instance variable. So by default, what are the values that are given? For integer value, it is 0, and for string, it is null value, empty string. So for that, I'll write employee and opening and closing parenthesis and an empty one. Now what is this? The method with the same name as of class is known as the constructor. By default, JVM provides us this constructor, which is also known as default constructor. Whenever this constructor is called, all the instance variables are given their default values. That is, I'm repeating again, integer it is 0, for string it is null, and for all the different parameters we discussed earlier, right? So this is default constructor, which is also provided by JVM, so we need not to implement this. Now next is that how do we give some other values to these variables? That is, I want to set, instead of empty string, I want to set ename. Instead of 0 value in eid, I want to set 100. Instead of 0 salary, I want to set 10,000 salary. So we'll write the code inside constructor. Constructor is a method which gets called the first time as soon as the object is created. See, you see the line here, employee e1, we are creating an object, and what is the first method that we are calling? New employee. So what is the first method that will be called? Employee. What is the employee here? It is a constructor. So inside this constructor, whatever we'll write will be executed first. So let me just write system and write from the constructor, right? Make sense? Now inside this tester file, I have set the salary, ename and id. I'll write e1 dot get eid. I'll just print this. So this get eid will return the eid for this object, this e1 object. I'll save it and let's run it. So you can say from the constructor, and this, and then 10. This 10 is printed from this statement because it is returning the get EID. Because it is returning the EID. What was the EID that we set? 10. See, we had to write the code to set the EID, but we want to automate this. And these two statements from the constructor, these were printed from these two statements. See, whenever, as soon as we declared or made two objects, this constructor was called, and inside this constructor we wrote this line which was executed, and so was the output. Now, as I said, that I want to automate the process and give my own default values to the field here, right? So I'll write this dot salary equals to 10,000. What is this? This means the object that we are talking about, the current object, right? Next is this dot EID. I want to set EID to 100 rather than 0, and this dot salary to, okay, I have already initialized the salary. I'll write this dot name, rename to maybe no name, right? So whenever I'll be creating a new object, what will be the whenever I'll be creating a new object, what will be the values to these variables here? Salary will hold the value of 10,000, EID will hold the value of 100, and ename will hold the value of no name. Understand? Now let me just remove these lines. Now these are no longer needed, and we'll try to print all the three variables here. So like so, inside the subject v1 dot get rename, and then write v1 dot get salary, right? See, I haven't written any statements regarding the set statements or any set functions here, so we just run it. And you can see 100, no name, and 10,000. I haven't written any set statements, I haven't used any setters here, but still I got the default values that I wanted. Why? Because I declared them right through this logic inside a constructor. So constructor is a method that is of the same name as the class and is executed the first whenever a new object is created. Okay, so this is the work of an employee. Now suppose I want to pass some values and set the values according to my needs. Now this is that it will be same for all the objects, but I want to pass or I want to set the values according to me. That is, whenever I am creating a new employee object, I want to give it salary as 40,000 maybe for some employee, and EID as 101, and ename as my name, right? So for that, what I'll do, I'll make a parameterized constructor. So first constructor that we discussed is a default constructor. Default constructor is without any parameters. Next is the parameterized constructor. As the name suggests, it will have some parameters. It is very much similar to methods only, that how we passed some value to methods, but the difference is that it is of the same name as the class name, does not have any return type, that is, we cannot return anything from the constructors. Please make a note of that. We cannot return anything from the constructor, be it be default constructor, be it be a parameterized constructor. So how do we make a parameterized method? We write the method, and inside the braces we write the parameters that we do. Okay, so for that, so let's make a parameterized constructor employee, and then inside this, what are the values that I need? Firstly, I need ename. Next, I need an AD. Next, I need a salary, right?
equals solve, right? Now, what am I supposed to do with these parameters? Whatever will be passed to this ename has to be stored inside the ename of the current object. How to point to the current object? Using this. So this dot ename, now this dot ename, that is for the particular, for the current object, ename value should be the value of, the ename should be equal to the value of this ename. This dot ename stands for this ename here, right? The object ename, and this ename on the right side is the local variable that I have used for the parameters. Please make a note of that. If I write a here, I have to pass a here. See, but it is a good convention if you use the same name for local variables as well as the instance variables to remove any confusion. Just make sure that for instance variable you have to use this. Okay? So I'll write that this dot id will be storing whatever eid I'll be passing from the constructor call. I'll tell you how to pass these values also, don't worry. Okay, so we finished writing up the logic in the parameterized constructor. Now let's see how we can pass. We'll go to the file where we have created our object. See, this empty braces will execute our default constructor. We discussed earlier the polymorphism, that is RJVM categorize, or rather I can say RJVM differentiate between different method calls based on the number of arguments, type of arguments, and the order of arguments, right? So if the parameters are empty, that is if we are not passing any parameters, the default constructor will be called. As soon as we will be passing some parameters, this parameterized constructor will be called, given that the order of the parameters are same. That is, if I pass ename, first it was ename. For ename I'll pass Sahib here, and next was a eid, I'll pass 102, and next was the salary, I'll pass 22,000, right? So let's save it and I'll give it a run. So inside this even object, what will be the values? For ID it will be 102, ename it will be Sahib, and for salary it will be 22,000. Let's give it a run and see what happens. Save it and you can see EID it is 102, for ename it is Sahib, and for salary it is 22,000. So this is how we call, or rather make, a parameterized constructor. Whenever we want to pass the values during the object making, we call the parameterized constructor. Whenever we want to give some default values, we use the default constructor. One more thing to note here is that these constructor, the return type, or rather I can say the access modifier, is public. That is, these constructors will always be public, because if they are private, how will we be supposed to access them outside the class, right? You understand this? So this was all about the constructors here. Now next is inheritance, right? So inheritance is a very important topic with respect to OOPS, because it structures the software, it structures the working of our software very much. So let's understand what is inheritance, what are different types of inheritance, and how we can implement inheritance in that Java program. So now let's understand what is inheritance and why do we use it. Inheritance in Java is a mechanism in which one object acquires all the properties and behaviors of a parent object. So make a note here, behavior means the methods and the properties means the data members. So as the name suggests, from biological terms, what is inheritance? See, we inherit some properties from our parents. Like you may have come across these statements that your face is very much similar to your mother or your father. Now, in the same way, Java uses inheritance to copy the behavior and properties from a parent object. That is, if I say that class A inherits the properties from class B, that means from where it is inheriting, that class becomes the parent class. So class B will be parent and class A will be the child class. Now it is very important for OOPS. The idea behind inheritance in Java is that you can create new classes that are built upon existing classes. For example, let me give you an example of a car. What are the basic needs of a car? 4 wheelers, AC and a steering, right? So suppose this is basic needs class. We created a class with the name basic needs, and there we just declared some variables and methods like 4-wheeler and some steering and AC. Now suppose we have to bring an update to the existing model. Suppose we want to add airbags in it. Now instead of modifying that basic needs class, we can create another class, and that class we can make that class to inherit properties from the basic needs class. That means the other class, the second class, the updated version class, will have all the access to the member functions of the previous class as well as access to the new function that will be added. That means the inherited class will have the members of the basic, will have all the steering and AC and 4-wheelers, and apart from that it will also have a property known as airbags. Okay. When you inherit from an existing class, you can reuse methods and field of the parent class. Moreover, you can add new methods and fields in your current class also, right? Makes sense? So we'll understand this, how to do in Java. And next is terms used in inheritance. We'll be using many terms like a class. We already discussed what is a class, a group of objects which have common properties, template or blueprint from which we get objects, right? What are objects? Instance variable for the class. Subclass or child class, a class which inherits the properties from another class. It is known as derived class, extended class, or child class or subclass. Next term will be the superclass or the parent class. As the name suggests, the class from where a subclass inherits a feature, right? Suppose that class A is inheriting properties from class B. Then class B is the parent and class A is the child class, right? Reusability. As the name specifies, reusability is a mechanism which facilitates you to reuse the fields and methods of the existing class. That is, you can reuse the methods, the variables inside the parent class in the child class. The child class will have access to its own methods as well as the public methods from the parent class. See, I used public methods from parent class. We'll see what are the different rules that we have to take care while inheriting properties from one class to another class. So let's get to the coding and understand how we use inheritance in Java. So we'll take an example from the employee class only. Now there might be two types of employees in a company. One is permanent employee and another is contract based. Let's make class for them. So inside this package, I'll create two new classes, one with the name permanent employee. Always take care of the names that you are giving, the name conventions, no spaces in the class name, and it should always follow capital. That is first letter capital and the first letter of another meaningful word capital, right? Signature. And you can see we have created a class permanent employee. Similarly, we will create another class with the name contract. So we have two classes, permanent employee and contractor. Now tell me one thing. Every employee will have his name, his employee ID as well as his salary. Right? Makes sense? So suppose if I write string ename here, private string ename here, and same all these getter setters here and all these variables again in permanent employee as well as contract employee. We will be increasing the size of the code as well as the complexity will also increase and will be understood by the reader or the code itself. Right? So for that we use inheritance, that is permanent employee is a type of employee. Contract employee is also an employer. So wherever we use the is a relation, that is known as inheritance. Permanent employee is an employee. Contract employee is an employee. Okay. So wouldn't it be nice if we inherit all these properties in permanent employee also, because these are common for all the these two classes, right? For permanent and contract employee. So for that we use extends keyword. Extends keyword is used to extend the property, that is this class is extending the reach of or the span of this class, that is this class wants to inherit all the properties of this class as well as use its own properties. So I'll write extends employee. Right? Now what happens now? Inside this permanent employee class we have all the methods of employee. And similarly in contract employee I can write extends employee. Right? So now the functionality of permanent employee and contract based employee are different, because see, permanent employee will have a fixed salary, whereas a contract based employee will have a salary based on the hours it has worked. Right? So inside this employee class, let me just make a new function. How we create a new method? Public void calculate salary. Right, it is right now empty, or rather I can say public double or int calculate salary, and it is returning the salary level, right? So this function in employee will return the salary of the employee in the calculate salary function. Now inside permanent employee, let me just declare a variable known as bonus, private int bonus, right? And inside this contract employee, I'll write private int days, plus private int days. So for contract employee, salary will be calculated based on wages into days, and for permanent employee, salary will be calculated based on salary plus bonus. So both of them will have different calculate salary methods, right? So this is known as function overriding here. Overriding means that, see, employee class have a method known as calculate salary. So inside this permanent employee's calculate salary method will be available, and inside this contract employee's calculate salary method will be available. But if we use this method, it will not give the salary based on our requirement. We just return the basic salary that we have. So now let's understand this permanent employee and contract constructor. See, let us create getters and setters for these private fields. For every private field, make sure you create getters and setters. So go to source and then create getters and setters. Select your variables and there you go. You can set the bonus and get the bonus from outside the class using the objects. These also I create the there you go. We have created getters and setters for both of these classes. Now let's create an object for them. Inside this tester class, I'll create an object permanent employee PE1 equals to new permanent employee. Now I'll get P1 dot and you can now I'll write PE1 dot and you can see all the functions that is accessible from this object. Now let's see what are the functions. Calculate salary function, it is from the employee class. Get bonus, it is from the permanent employee. Get class, okay, it is object function. Get EID, it is from the employee class. Get ename, it is from the employee class. So by making an object of permanent employee, I am able to access the methods of this employee class, but make a note here, I am not able to access these private data members directly. I can access them using these getters and setters. So there is no chance of accidentally changing their values. I have to use the setters and getters to get them, right? So I will write get EID. So now I'll just click to print this out and see what is the values that I get. Save this out and just comment this out. And you can see 100 is being printed here. Why? Because inside this employee constructor we have given that whenever this default constructor will default, the default value for EID will be 100. From where we are accessing this? From the permanent employee object, right? Similarly, we create a contract employee CE1 equals to contract employee. Similarly, on this CE1 also you can see all the functions that are accessible from this. All the functions that are in green are accessible from this object, right? So this is inheritance. Now we have different types of inheritance in Java. We have single inheritance, multi-level inheritance, and hierarchical inheritance. So in single inheritance, one class extends or inherits a property from another class, that is single inheritance. Next is multi-level inheritance, that is one class extends from another class and then the second class is extending the property from the third class. Multi-level inheritance is not supported by Java, so we'll discuss why it is not supported next step. So we have multi-level inheritance where one class will extend property from another class and the second class will inherit the properties from the third class. So in single you can see that class B is inheriting properties from class A, that is class B will contain all the method functions, methods of class A. In multi-level, class C will have the methods of class B and class B will have the methods of class A. That means class C will have both the methods of class A and class B. In hierarchical, we have that class B and class C both will have the methods of class A. So which inheritance did we use in the employee structure? It is hierarchical inheritance, because our permanent employee and as well as the contract employee is inheriting property from a single class, that is employee class. There are other types of inheritance also, like the multiple inheritance, where one class inherits property from two classes at the same time. See, Java is already very complex, and to remove this complexity, multiple inheritances not supported with each other. And to get over that, we can use interface. Don't worry, in the later part of video, we'll discuss about interface, using the interface. But by this time, these are some different types of inheritance. So single inheritance is like when we are inheriting permanent employee, and we are using permanent employee to inherit the properties of employee. So that is single inheritance. But when at the same time, same employee class is being inherited to permanent employee as well as contract employee, that is known as hierarchical, right? So this is all about inheritance. And so now let's understand the order of execution of constructor. See, we faced a problem in our class that let me just show you. In our class here, when we created the object of permanent employee, there was no method that I can use or where I can give my desired values to the employee, right? So we'll see how we can do that. We can directly pass these values to the permanent employee constructor there, right? So firstly, let us understand what is the order of execution, right? So an employee, yes, I'll write. So employee constructor call, right? So whenever this constructor will be called, this statement will be executed, and you can see that in the console. Let's make a constructor for permanent employee as well. Inside this, I will write a system statement, starting with permanent employee constructor. Right. Okay. Let's give it a run here and see what are the order. What is the order of constructor? And you can see these two are from these two lines, right? So let me just remove this. See. Let's run it again and see what happens. There you go. Employee constructor called, then permanent employee constructor called, then employee constructor called. What are these? When I created an object of permanent employee is inheriting properties from employee. So whenever this constructor will be called, firstly, whenever we'll be referencing this permanent employee, okay. So whenever this constructor will be called, it automatically calls the parent constructor first, then executes rest of the lines. So when it called the employee class constructor, this statement got executed and these values are set up, right? So after that, it printed its permanent employee constructor. And for the second statement, we created an object of contract employee. We don't have anything inside the constructor of contract employee. That's why we can't see anything to be displayed. But the constructor, the default constructor is automatically given by JVM, and the default constructor automatically called the constructor of employee, right? So, but this method, using this method, only the default constructor is called. What if I want to give name employee ID and salary to a permanent employee. To do that, we use the super keyword. Super keyword. So super keyword is used to access the member functions of the parent class inside the child class. For example, inside this permanent employee, let me just create a constructor, parameterized constructor this time, string name and int eid, then int salary, right? So from this constructor, I want to call the constructor of the upper class, the parameterized constructor of the upper class, that is the employee class. So I'll write super, and inside the super I'll pass the parameters that is to be passed, that is name, eid, then salary. There we go. So whenever I'll pass 3 values to this permanent employee constructor, this line will get executed, and this will automatically call which constructor of employee? The parameterized constructor of the employees, because I'm passing 3 parameters here. Understand? Makes sense? So the parameterized constructor of employee is being called in the value cut setup. So if I pass same values, Sahib, then 102, then 22. I'll save it and go to the this comments. Instead of keyword, which constructor or which object we are referencing, the E1. So now let's give it a run. So you can say 10. So you can see 102 Sahib and 20,000 has been called. So this get ID is in which class? Employee class. Why was it accessible from the E1 object? Because this class is inheriting properties from the parent. See, now one more thing. A child class can access properties of a parent class, but a parent class cannot access properties of a child class. Let's understand this. Inside this permanent employee class, let me just create a method public void child method, right? So you can see by making an object of permanent employee here, this PE1 object was able to access the methods of parent class. Let's try making this I have created already, right? So I'll make objects of a employee class. Now you see, I'll write E1 dot dot see. I cannot see any child method here. Why? Because E1 is a parent class object. The parent class object cannot access any methods, any variables from a child class. Sure, make it a note, and it's very important concept. So please make sure you are getting it. A parent class cannot access the methods or parameters. A parent class cannot access the methods from a child class. A permanent employee was a child class, and the object of permanent employee can access the parameters from the parent class. Okay. Now one more thing, instead of this permanent employee, I can simply write employee also. Right? A parent class can store the values from a child class. A parent class object can store the values from a child class object. Understand? But a child class object cannot store values of a parent class. That is, instead of this employee, if I write permanent employee, to show an error that permanent employee cannot create an object from the employee, right? So this is all about the constructor calling and how the values can be stored. Okay. So now let's understand the concept of constructor, or rather I'll say function overload, right? Now see, we have a calculate salary method inside the employee class, but for permanent employee the calculate salary method is different. So I can write calculate salary method here, right? Now it is saying that it is right because in employee class the type is double. Is a double. So this method must return. So I'm very good to this return 0. Okay. Now let's understand this. If I write here in system, if I write te1 dot calculate salary, which calculate salary method will be called? Let's run it and see it. So you can see 0 is getting printed, that is this method returns 0. The employee class method will return salary, that is 22,000 in our case, but it is returning 0, that is whenever we have same name function in the child class, so the child class function will be given here. Precedence, that is this function inside the child class will override the function in the employee class. Understand that? This is known as function overload, right? So this was all the basic knowledge of inheritance and how constructor are called and what is out of constructor call, how we can override functions. For better understanding of function overriding, you have to practice a lot, right? Practice for 2 or 3 questions. I practice a lot of questions. For that we have different websites. I'll write the links inside the description, and we also know where to study, right? And let's understand the last concept in object-oriented programming system, which is encapsulation. What is encapsulation? As the name suggests, encapsulating different properties inside a single capsule, right? Encapsulation is derived from the word capsule. What is a capsule? We contain all the different properties inside some single entity, right? So let's see this employee class. Inside this employee class we have our constructors as well as our methods as well as our data methods. So inside a single class we have encapsulated many things, right? See, for a single integer it can store only integer values with some range, but inside a class we are able to store 2 integers, 1 string, and different methods. This is known as encapsulation. It's a very small concept actually. So this makes this
अरे बता दे क्लास बता दे तूने जो डिफाइंड, अरे बता दे टीचर बता दे.
So anyway, so this concept ensures that our structure is well modular, that is, it is divided into different modules, and each module is having its own properties, data members, and the functions. So this was all for this video. If you like this video, this was the first part, and see, a lot of efforts goes into making these videos. So I hope you like the video and subscribe the channel. Please share it with your friends. The next part will be discussing the abstract classes, interfaces, and the collections APIs. So I'll try to upload this as soon as possible. So press the bell icon so you get the notification of the new videos that I upload. Thank you so much for watching this video. Hope you are having a nice day. Goodbye.